Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. This is the second lectures. I did not receive any comment about the previous one. It means that was acceptable. Today we will talk about differentiation. So it is in chapter 11. And we will start with the differentiation here, derivative. Well, derivative is very simple here, just based on this equation here. And that one here, which we call Taylor series expansion, which goes back to the calculus 2. And it's better to write it like this here. We can write it fx plus h, which is equal f of x plus h prime of x plus h prime double prime divided by 2 factorial and so on. So we'll try to find the approximation of the first derivative, and the other will be similar. So now this one here, this is equation, because we would like to approximate this one here, so we don't care about the others. So this one here, it means we'll stop here. That's the approximation. It means the rest are the error. So this one here equal this, f prime clearly equal this, divide by this. So here is the approximation, which we call it forward difference approximations. If we write x is xi, it will be written like xi plus h, like this one here, divide by h. Or can be written like this as well, like this if we use the function. And we use the notation here, delta fxi divided by delta xi, which mean forward difference formula, backward difference formula, which we are going to use later on. So here now, go next slides. And here again now, we would like to derive the other one. But here really, it is, I think, no need to divide by h, but this is the note. So I will remind you later on how to do it in a simpler way. So same things, but here instead of writing of x plus h, we'll write it fx minus h. And later on, we'll continue. So if we take that formula and replace h by minus h, then we obtain the new formula. So this formula can be seen as follows. Look here now, we can see this is minus h. So just replace h by minus h. So here this will be negative. Here remain positive because minus square remain the same. So as before, we write this one. We'd like to find f prime h. What is it equal? Take this one left hand side like before, we obtain this result. So again, this one can be written like this. So this one right like. So at that point here minus the previous one. And here remain is h. So we can write it like this, nabla fxi divided by nabla xi, which is called backward difference formula. So there are some other things can be written like this one here. We will find central difference formula, and we will see how it goes now. So to find that one final difference formula, look here, we copy now f of h plus, and here just h minus h, and this one when we add them, subtract this from this, we obtain this one. So we'd like to find this derivative here. How to find it? Just divide by 2h, you will find f prime equal this approximations. And the error, here is the error. So that one here, and this can be written, well, it's not like here delta fxi, because we have to write it minus a half here, so this is not correct in fact. So it should be, but that's correct here. You notice this always this number minus this number here, it will be in the bottom. So now we will have to explain now how to calculate the error. The remaining things give you the error. Like this one here, when we write this one here, central difference formula, we can see this is the remaining thing is called error. But this is here because it was dots like here, many dots here. These dots, all of this here, replaced by derivative, and at point here eta, where eta between x and xi. So this is really the error. We call it local truncation error. So this one equal this, and this is the error. So now here we have to go to next slide. So we are always taking h, it means xi minus xi minus 1, or xi plus 1 minus xi, or a half minus this one a half. So this one here, which we talk about here, central difference here, This is here, just replace h by h over 2. So it will here plus a half, here minus a half, and still this minus this remain h, which mean from here to there. So this one now can be written delta fxi divided by delta. We call it delta as well, even this one looks like the other one. That one is capital delta, this one is small delta. So this is really the approximation. So now we would like to have some summary, how to make this one. In fact, the derivative is here. So just written delta over delta, or nabla over nabla, or delta small delta over this. And we call this one forward, backward, and central difference. What does difference between forward? Forward, this is delta fi. It means we take this I and add 1. So it is fi plus 1 minus the same one. But backward, no, the same minus the previous one. So this one called, but central, it means a half you go forward and a half backward. So this called central difference formula. We have to remember those one because we are going to use them a lot. So here is the next slide. So for example, just to exercise this, very easy here, everybody should exercise this one. If I ask you what is delta square of I, which we need to remember for the futures. So it means apply delta 2 times, so this is delta 1. So this delta 1 here, it's equal, as we said before, fi plus a half minus fi minus a half. Again apply delta again, it means add a half here, and subtract minus a half minus a half. You will find this one. Simplify, you will find this. I always remember this one. You should remember it like me. But this is here wrong. This is not negative. This is plus. So the answer is fi plus 1 minus 2 fi here plus fi. So this one should be plus here. Okay, just I put it in red color. It's better. So this should be plus. All right. So that's it here. So anyway, so this we have now delta. If you want to do the other thing, just exercise this one. It's not difficult to do so. So now here, this is just again we're writing what we are doing this. Okay. Now we would like to exercise those problem and give some exercise. For example, we would like to approximate the derivative of sine x. Well, we know the derivative is equal cosine x at x equal 1. So exactly we know how it is, and we'd like to approximate this value, assuming we don't know. So in that case here, if we take forward, it means this is forward. So we have to write x plus h. What is here x? X, he told me at x equal 1. So it means 1 plus h. H, he gave it to me. He said somewhere here. Here it is. He assumed h equal 0.01. So add 1, it will be 1.01. So here the function 1.01 minus f of 1, which means sine 1.01 minus 1. And here this number minus this number, it means h.01. Of course, this the function is sine, so just calculate sine this minus sine this, use calculator value, this is the answer. So again now, repeat again, so we are using forward central formula. Remember the error is h times something, so we repeat for backward. This is backward, the same point minus the previous one, which means at 1 minus 0.01. So in this one here, so in that case here, we have to see this here, divide by this. Again, substitute as before, here is the answer. What about central difference formula? Here is a plus a half and here minus a half. So half mean h here, it means 1 plus 0.005 minus this one here. And remember this always this minus this, which means always here h. And this one, if you calculate it, this one is like this. Use central difference formula. We obtain this result here. Just to see our result, we would like to find the error. Because we know how to find the derivative exactly. The exact answer is here, the exact answer. Cosine 1. So the error is the exact answer minus the error, exact answer minus the error, exact answer minus the error. It's clear that the best one is here. This is the least error. Why? Because the way we found it here, the error was something h square, we call it. But that one h, so clearly we expected this one is better. So in fact here, central difference formula is much better. So now I like to give here just summary, because really when I look at the note is not clear enough. So Here is the summary. I mean, that's what you're supposed to do when you study. The summary, all what I say is like this. This is very important here to say. This is Taylor series. Everybody should know. Goes back to calculus 2. And then he will have this one here. If I want to approximate this derivative, so just look here, cover this one here. So don't look at this one here. So here the answer. So f prime equal this, take it left hand side, divide by h, you will find this answers, which we call it like this. Now if you replace h by minus h here, you will get this one. Again I want this, so I will forget here, this is the error here. When I forget this one, again h prime equal, take it left hand side, this one left hand side, you will find this, very easy. And local truncation error is the mirror here, the remaining things. But remember, we'll replace x here by eta. And here same thing. But for central difference, I like to take this minus this, so 1 minus this one, which means you will get this one here. Now here, when you take this minus this here, it means fx cancelled. Look here, it's immediately here h cubed, so which means really better than the previous one. So the error is power 2 here, but here power. So clearly this one, the central difference for is better. And there are many other formula if I like this one, the previous one used this one 2 points. If we use 3 points, there is a way. For example, this is a formula. There are other formula in the book. So this is not difficult to verify. Just substitute this one from here. If h plus x plus 2. How do you find this one here, x I plus 2? Well, just this one, we know this one, I plus 1 is given here above, x plus h. But this is x plus 2h. It means replace each h by 2h. So this one remains the same. This is 2h. This 2h becomes square, which means 4 square. Divide by 2, it becomes like this and continue like this. And so that substitute here, you will find the error, which is not difficult to find. So that's really, if you want to take another example from the book here, there is another example. He gave you the x and give you y. And he asked you find the derivative at x2 using forward formula, which means given here. Explain very well here. Backward formula, central formula, and also this is a new formula with 3-point formula, and so on. And clearly he found the answer. He did not tell you how did he get this mark here, these numbers. In fact, was from here. But you don't need to know. I mean, this is the, what is it? So this is some idea. So to repeat this idea, just the same thing, but we like to do it for second derivative now. So this one here, if you want to find the error, that one is 3 points. Just substitute Taylor series, you will find the answer. So if you want to find the second derivative, look here, it is the same as before, but we continue here until we find the second. This is the second derivative. It means we ignore this one. So what is it, this one? How do you find this? There is here first derivative. It means we take this plus and this minus. When we add them together, look here, plus minus, this cancel here. So we'll have the answer here, second derivative. No if derivative. Just solve this equation. We find this one here very easily, and now we know a formula for the second derivative, which is this one. So now second derivative is equal this formula which we found it delta square if I divide by h square, we found it there. So this is really the approximation, and now just continue in this way here. If you want to take other example here, just substitute here. He's not doing a lot, just Taylor series, and using like forward, backward here if you want. All right, so and just continue here in that case here again using this one. So, and that's here, this is the end. Okay, and see you next lecture. Assalamu alaikum wa rahmatullah. If you have any question, please send me an email. Assalamu alaikum.